Hey everyone, welcome back. So, every once in a while, you just want a new toy. Not because you need it, but because it looks cool. And so we have today the Tiny Spectrum Analyzer. This cost me about $54. It looked interesting, it looked cool, so I figured, why not get one? Inside we have the TinySA itself. It's pretty small. So tiny definitely describes it. Comes with a little pick, whatnot, for working on the touchscreen. Comes with a USB-C cable. This is for charging and hooking up to a computer. We've got a female SMA connector. Got two short male SMA jumper cables, and we have a telescoping antenna with the male SMA connector. So I'm gonna put these pieces to the side. We'll peel off the plastic. Let's have a look. I really don't have a whole lot of need for a spectrum analyzer, at least not a radio frequency spectrum analyzer. But like I said, $50, kind of hard to pass up. Let's turn it on. And there we go. It's a nice looking screen. It's got menus are on the right hand side. So let's go in. Let's do a self-test. I do know that to do the self-test you need to wire the low and high ports together. Let's put them together. Let's do self-test. Self-test complete. Touch the screen. And we can do a level calibration. Let's reset and calibrate. Calibration complete. And as I read online, that's all it takes to set it up. There's a low and a high band input. The low band input has got attenuation. It's just a general better sensitivity. The high band input is not quite as useful. At least that's what I hear, but it's been included. One there. I'm not going to profess to be any kind of an expert at using this, but we'll play around with it a little bit just to see what it does. So I'm going to be using my UTG-932E function generator to put some signals into this. And I'm going to use an SMA to BNC adapter here. Let's put that on there. And let's get a BNC cable here. And let's put a sine wave in, and just to be safe, let's do something relatively low here. We'll do 200 millivolts, peak to peak. Let's turn it on. And let's see what we get here. And we get one point that's up here. And the problem is we are down below the frequency that this will support. So let's get up to 1 megahertz to start. Let's see here. You see just on the left hand side, you can see we're at 8 megahertz, 9. Let me get up to 20. There's a 20 megahertz signal. And if we look here, we can show our first marker point is showing us at 20 megahertz. And it's a minus 15 dBm signal. And you can see we've got a couple harmonics coming off there onto the right. So if I change the wave type, let's change this to a square wave. Value is out of range. Okay, so we can only do 15 megahertz max square wave on this. You can see we've got more prominent what look like the odd number harmonics. Let's frequency center, let's say 15 megahertz. There we go. And if I take this, start to sweep it down, and see it move over. If we go back to sine wave, there's our 15 megahertz sine wave. You can see we start to sweep it up. You can see 22, 4, 24.977, so this is a 25 megahertz wave. So it definitely looks like it's working. Let's see, what else can we do with this here? Start and stop frequency, center frequency, span. Let's look at that. So let's look at a span of, I don't know, 5 megahertz. Oh, that's not good. Span of 1 megahertz. That's not good either. That's definitely not good. Let's load the preset. Start over. So I obviously need to read some instructions, play around with this a little bit, but it 15 megahertz. It seems pretty cool. Let's see here. All right, so the low frequency band is from 100 kilohertz to 350 megahertz, and the high is from 240 megahertz to 980 megahertz. So yeah, like I said, Not quite sure what I'm going to do with it. I'm going to have to read up a little bit more on it, play around with it. But it is definitely a cool little piece of kit. So yeah, that's about what I would expect to see. What is the span range on this? This has got a span of 30 megahertz. So let's try frequency span of 100 megahertz. So yeah, we can definitely see the odd numbered harmonics there. So we get back down to a nice square wave. It's 1 megahertz. Let's center it at 1. And let's try again. Span of, I don't know. Yep, there's all of our harmonics going downward. So it seems pretty nice for 50 bucks. Construction seems okay. It's very lightweight, but it's not going there. Oh, that's interesting. That looks like it's flashing at the update rate in there. Kind of cool. But yeah. So new toy, TinySA. Like I said, don't have a big use for it at the moment, but like most things, I'll figure out something to do with it. One other thing that it does do, which is nice, is it will act as a signal generator. Let's see here. I should be able to use this as frequency counter, utility counter, and I believe if I come in here and say switch to low output, there we go, and turn that on, and I am not seeing anything. Well, when in doubt, use a real frequency counter. So let's just pick this up for a second. So if we look here, you can see we're outputting 10 megahertz signal, and a counter is showing here 10 megahertz. So that seems to work. That's the TinySA. There's definitely more in-depth videos out there on it. I'm going to need to watch a few of them, see what I can do with it. If I ever get into doing any radio stuff, I'm sure it'll be a lot more useful. But in the meantime, like I said, sometimes you just want a new toy, and this seemed pretty cool. So yeah, 50 bucks, I would say definitely go out and get one, especially if you're doing radio work. I'm sure it will prove quite handy. All right, that's it for now. Thanks for watching. Catch you all later.